Southern Manufacturing 2025. We're here at Farnborough International Exhibition Centre. Terry,
Yes.
on the Whitehouse Machine Tools stand. It's a big stand. You've only got one thing though. You're showing off a fascinating piece of equipment. What are you showing off today?
So this is one of our, we've had some real success with this. This is a full 5-axis multitasking machining centre from the Brother Speedio M300Xd1.
But you show the camera the part that you guys are making today.
Yeah, so this is the example part. It's turning and milling in one setup, showing off the machine. So integrated in one clamping, we have turning, we have milling, we have 5-axis, we have 28 tools as standard, we have tool measurement, and it's a really productive solution is what it is.
Yeah, and if you look inside the side of the machine, the size of the spindle on that bottom C-axis, the turning spindle, absolutely huge. So this is capable of turning, milling, like you said, completely multi-axis. And what is something you think people should know about Brother machines like this? This is obviously a really high spec one, so it's impressive by itself. But the standard kind of Brother VMCs as well. What should people know about the Brother range?
Well, it's Japanese production technology. It's designed to run 24/7, but it's actually really cost effective. So for batch machining, if you want to get more done in less time, it's something to really look at. And we've had a lot of success with this model in particular and the smaller version of it for integrating 5-axis components and turning into one setup.
Yeah, absolutely. Compact. And you get from that machine, you get this part basically off in one hit.
Off in one hit,
and there's a lot of benefits to that as well, aren't there?
Absolutely, yeah. You know, it takes the lathe out of the equation. Everything's a bit more accurate because it's all together. It's productive.
And what's amazing is on aluminium, on such a small diameter as well, you get a really nice finish. So you've got obviously a decent RPM that can get up to the cutting speeds as well that you need to.
Yeah, so it's 1500 RPM on this one, and on the smaller machine it's 2000 RPM on the turning, and then we're usually supplying 16,000 RPM spindles on the milling side.
Fanuc robot, very well known, but what it's integrated with is an off-the-shelf solution available as well, isn't it?
Yes, so this is the Tezmaksan CubeBOX system. So it's drawer-based, it's modular, it's plug and play.
You can see the drawers coming in, so it's literally running live. You're running these all off yesterday and today.
Yeah, so we're billets in, we're components out, we're drawer-based. The operator gives the robot a full drawer of components. The array of parts can be whatever they need to be, square billets, round billets, different sizes. The robot then goes away and tends the machine using that drawer. It can give the drawer back to the operator and then start working from another drawer. So the capacity that you get from it, it's actually quite a lot of hours from a small footprint.
You look at the billet density in there is huge.
Yes.
Now, before we go more into the details of how the CubeBOX works, why would you automate a machine like this?
Well, I think what the machine itself gives you is something fast, compact, reliable, that can make parts quickly. And then why would you not automate it? You know, do what you're doing productively for more hours.
There's no point reducing the cycle time and changeovers in this from 3 ops, let's say, to 1 op, and from, I don't know, an hour because it's been sat waiting in a box waiting for someone to load onto another machine down to 30 seconds. If you've got it waiting 5 minutes for someone else to go and load a new one in.
Yes, exactly. Yeah, I mean, what you've got on the other side is trays of complete components.
Absolutely.
You know, ready for next operations, measurement, whatever you need to do. And
I guess that you probably can't put hard numbers on exactly what the return on investment this would be for a specific customer. But from a business point of view, why would you buy these machines in tandem?
Yeah. From a machine point of view, it's more cost effective than people think. You know, it's like we said before, it's Japanese production technology, but they don't cost the earth. When you look at cost per part and what you can get from a multitasking solution, it really does add up well.
Absolutely, brilliant. So thank you very much, Terry. We're going to go over and have a quick talk to Dan Hayes as well. Dan.
Hello.
Hello. Thank you. So you've been running this machine pretty much the past 2 days.
Yes.
Can we have a quick look at the drawers? I know there's a lot of customers around looking on the Whitehouse stand. Sorry, guys. Could you tell me a little bit about how these drawers work, and how customers will load up parts, and how they'd see it running in their shop day to day?
Yeah, so basically the trays are configurable. So at the moment we've just got a laser acrylic template based off of DXF, and then we could have these. At the moment we're using round billets, so we've done an array of components as an incremental pitch, and we've just staggered them out equally, so then it's just nice and easy for clearances of the robot, but effectively it will pick it from front to back, working from left to right. It will obviously work out its quickest route of pick up and place. And yeah, we're loading into an automated pneumatic vice.
Yeah. And when you say configurable, I'm just trying to spell it out, but it means that you've got two drawers here that have got round billets, and down here you've got some completely different types of parts.
Yeah, so these trays, we've gone with a rectangular on here to effectively nominate a corner. So we'd have a round billet, whether it be 1 inch, 2 inch, 3 inch, or whatever. We would push into the nominated corner, and then that's where we would tell the points. So that would be part 1, 2, 3, and 4. So although it's a simplistic template, it gives you more versatility with what components you put into there, because you just push into the corners. And then the tray system is based off, you're in the loading bay, so once I'm not going to put my hand in it, but once you then break the signal, you're in the loading area as such. So you load the tray up, you push it into the robot area, and when it's in the robot area, you nominate that the robot's now running, and it will then work out, on this tray, etc., and it will work the way, or work its way down from tray to tray, and once it's finished the tray, it pushes it back into this area.
Do you have to do a lot? I mean, how does the programming work for a changeover for a brand new grid plate?
It's fairly simplistic. It's obviously an industrial robot, and the software does it for you effectively. So you've got underneath this running control at the moment, you've got a load sequence. So that could be load a single machine, load 2 machines, or whatever, or load, and then I do a wash-off system, and then place. You can configure those bits, and they're just kind of just a simplified app. You go point by point and then task by task. And then when we were going over the trays, it's on the placement, etc. So you would nominate the DXF suited to the code component. So that could be a casting of some sort of shape. And then the DXF has the nominated origin, the X and your Y plane, and that creates the flatness. And then that determines the positions and the pick position. So once it's taught and in place, you don't have to keep reteaching the robot. You load the template to the datum, and then that's it. Away you go. That's it. Load the right program, run it through, and then the robot then tells the machine to select the correct running program, and then that's it. Just loading and unloading components.
User experience is a really important point when you're looking at off-the-shelf automation system.
We manipulate the robot so it's up out the way past its home position, and it allows us to have full access to the machine, to cater for the machine, to do wash down, etc., do the setups. This is literally just to stop people from breaking the beam sensor, and that sensor can configure it to an area. We have customers, they put the garage flooring down and nominate, say, a red area and an amber area. So amber, where myself and you are standing, this will be a slowed down machining method, and then when you go into the red, it stops and puts itself into a safety sim.
Absolutely.
Area.
So that's automation built for the shop floor, high spec machinery, really compact automation, all supplied in the UK and Ireland by Whitehouse Machine Tools.